All right, everyone. Well, without further ado, good morning, good afternoon, good evening, wherever you are, and thank you for joining us for another one of our partner webinars with CircleCI and NeuVector. My name is Christopher Black. I'm a Senior Solutions Engineer with CircleCI, and joining me today is Glenn Kosaka, VP of Product Management and Marketing at NeuVector.
Hi there, everyone.
Okay, super quick run through the agenda. We're going to do a quick round of introductions, talk a little bit about ourselves, our backgrounds. Going to spend a little bit of time talking about CircleCI and more specifically a really cool feature on our platform called Orbs. We're going to spend a lot of time talking about NeuVector. It's a really awesome product. We're going to spend a bit of time talking about the NeuVector Orb in particular. And then we're definitely going to have a dedicated section for Q&A at the end. So we're definitely going to save 10, 15 minutes at the end for dedicated Q&A. Introduction. So again, my name is Christopher Black, Senior Solutions Engineer with CircleCI, and I've been with the company for about 4 years. Some might say that's a lifetime in this industry, but I absolutely love the company. I love the space. I love the product. I transitioned into solutions engineering about 2 years ago. It's kind of the best of both worlds. Some say I've fallen to the dark side, but it's the best of sales. It's the best of engineering. And above all, it gives me the opportunity to speak to really awesome technologists across the globe. Glenn?
Thanks, Chris. My name is Glenn Kosaka. I run product management for NeuVector, and I've been with the company almost 4 years, since right before we launched the company. We're a startup company, and typical startup in Silicon Valley, and trying to change the world and help customers move to secure cloud computing. My background is in typically enterprise software and security, both at large companies like Trend Micro as well as previous startups.
Awesome. Thanks, Glenn. So CircleCI, our mission is to make it as easy as possible to go from idea to delivery. And really what that means is that we're trying to narrow the distance between idea and implementation. So CircleCI, we're a CI platform. We were founded in 2011 with a very simple premise, again, to help customers of all shapes and sizes build better software quicker, more reliably. We re-architected the platform in 2017. We broke the monolith up into a series of microservices, and we launched CircleCI 2.0, which has just been an absolute game changer. We embraced a service-oriented architecture. We embraced Docker in a pretty serious way. And as a result of our architecture, our scale, our company's history, we're running about 1 million builds a day now, well over 30 million builds a month, which really speaks to our scale and just the sophistication of our platform. And this is kind of where we see ourselves in the overall SDLC. We believe that we sit very comfortably in between a customer's source code repository and their end runtime environments, wherever that may be, right? It could be mobile applications, it could be infrastructure in the cloud, what have you. We feel like we sit very comfortably in between the customer's VCS, their source control, and their runtime environment, which is a really exciting place to be. And then super quick demo, just give everybody a kind of a walkthrough of the platform. So what I have here is a very simple Go application. It's a very simple Go web server. I imagine this is a lot of folks' first time seeing a build page in CircleCI. There's a lot going on here. I just want to point out, though, especially in contrast to other CI providers, adding a new project, it's really just a matter of clicking Add Project in the UI. I write a configuration file. The configuration file is written in YAML. Once I've done that, I have a fully scalable CI/CD platform at my fingertips. It's remarkably powerful. You can take a quick gander at the configuration file over here. The configuration file is written in YAML, simple declarative syntax, and the configuration file is very much the source of truth on as far as what to do with your build on the platform. The configuration file specifies not only what steps to execute during the build, but also things like, for example, if I'm running my build inside of a Docker image, well, which Docker image am I running my build inside of, etc. As we talk about CircleCI Orbs, it's a really important consideration that historically every project had to have its own configuration file. And historically on CircleCI, every project more or less corresponded to a single Git repository. Well, thankfully, within the past couple of months, we released a really, really powerful feature we call Orbs, which enables shareable templatized pieces of configuration that can be shared across N projects on CircleCI. And the long and the short of it is with Orbs, this has greatly enhanced our ability to integrate with third parties, integrate with third-party services like NeuVector. Wouldn't be a demo unless I actually ran a build real quick. So I clicked Rerun Workflow. Just going to click on the Workflow tab real quick. And again, very simple Go application I'm building, but we see all of this happening in real time. And again, wicked easy to get set up. I just click Add Project in the UI, write my configuration file, and I'm good to go. That more or less concludes it for the demo. Just wanted to give everybody a quick peek at what the platform looks like. Again, having established a little bit of context, historically every project had to have its own config file. But with the advent of Orbs, we can now templatize and share bits and pieces of configuration across N projects in CircleCI. And really what that means is we can templatize all of it. We can templatize the individual commands to be executed during runtime. We can templatize the executors themselves. What are executors? The executors are the things in which we check out code, and then we run whatever arbitrary commands are specified in the configuration file. A good example of an executor would be Docker, for example, right? I'm checking out code inside of a Docker image that I specify. I'm running a series of arbitrary commands inside of Docker image, etc. Lastly, we have the ability to templatize jobs themselves, and specifically workflow stanzas. Workflows, pipelines, these two terms are oftentimes interchangeable, but a workflow effectively is an orchestration of jobs, a stanza, if you will. Well, as you can imagine, being able to templatize bits and pieces of that stanza is incredibly powerful for all the reasons you can think of and more. And again, Orbs has really enhanced our ability to integrate with amazing third-party providers, some of which are listed down here. And a great example, of course, would be NeuVector. So let's say you wanted to incorporate NeuVector into your build pipeline as part of your workflow. We'll spend a bit of time talking about this, but rather than writing all of that config from scratch, rather than reinventing the wheel, all you have to do is just invoke an orb, you pass in a couple of parameters, and you're good to go. We're going to make this available for posterity, but here's just a compilation of resources, docs, the orb registry, etc. And again, we have dedicated Q&A at the end. So please, please, please ask some questions. And I think, Glenn, at this point, I turn it over to you.
All right. Thank you, Chris, for that great overview of CircleCI. A little bit more background on NeuVector. We are a full lifecycle container security platform. So we cover the entire gamut to enable you to build security in from the DevOps part of the pipeline, the CI/CD part of it, all the way into runtime. We were founded as a company that was really focusing on the runtime environment. So as customers moved these containers into production, how do they monitor and secure those? And I'll show you what we could do there. But over time, what we heard from our customers was they wanted to shift security left. You may have heard that term, shift left security, which really means they wanted to build security into the pipeline at early a stage as possible and at all points into the pipeline. So I'm going to talk about what the issues are, what the security issues are, what the threat vectors are in that pipeline, all the way from DevOps into the runtime environment. Awesome. And I'm going to let Chris control the slides. So next slide.
I'm driving.
All right, so everyone is trying to move to a very automated, rapid deployment pipeline, CI/CD pipeline. And as Chris talked about, CircleCI can manage that pipeline from dev all the way into the creation of the Docker images. And then those are going to go from that pipeline into the production environment. And once they get into a production environment, all kinds of dynamic things are going to happen with typically Kubernetes managing all that. There's going to be incredible scale of these microservices and pods scaling up and scaling down. There's going to be an explosion of east-west traffic, and that's pod-to-pod traffic. This is network traffic that we haven't seen before because previously you had a big monolithic app. And now you're going to see a ton of internal east-west traffic that could contain attacks in them. And there's virtually no visibility into not only that traffic, but what's happening in the containers. As Chris mentioned, in that dev pipeline, there could be the introduction of vulnerabilities if you're using open source packages and libraries and tools. In fact, we've got several blog posts that show how there were many backdoors built into some of the most popular Docker images. And even if you've done everything to remove your vulnerabilities, you could have an insider get into your infrastructure, either through a phishing attack or a brute force attack. So really the main challenge from a security perspective is how do we build security into that pipeline so that it can be as automated as possible, because in this environment we can't we can't use the traditional tools and processes for it.
Well said.
So here's an example of full lifecycle security from DevOps to runtime. We're going to start with the build process that Chris talked about with the CircleCI pipeline, and I'll talk about how we can trigger that orb to trigger the vulnerability scan from this CircleCI pipeline. Typically, then the images are put in a registry, and then we're going to continue to scan those in the registry, because it's possible that images could be put in the registry without going through that process, and perhaps not even being scanned during the build process. Or images in registries could have new vulnerabilities that are discovered after they've been put in the registry. And this is going to continue into the runtime environment with runtime scanning and CIS benchmark audits and compliance checking all the way into runtime. But the most critical things to do during runtime to really protect against attacks are, first of all, prevent the deployment of unauthorized or vulnerable images through admission controls. And then as your containers are running, to be able to use what's called a container firewall to inspect all of the network traffic between the containers, as well as in and out of the infrastructure. And also to be able to inspect what we call container workload security. This is where we can inspect all of the activity within every pod or every container to make sure that there's no malicious processes or file system activity going on. Next slide, Chris. So at the early stages of the pipeline, here is how NeuVector would fit into that CircleCI pipeline. So you can see the various steps of the pipeline. And at that red step there, you can see the NeuVector vulnerability scan. This is where the orb for NeuVector could be triggered, and the results could be then passed back into the CircleCI build process. So there's automated build phase scanning at that point. And then as they are, the images are passed, they can be put into a registry, and then the registries will be scanned and monitored for vulnerabilities as well. And those could be public cloud registries on the Amazon, Google, Microsoft, IBM cloud, or they could be private registries or third-party registries such as JFrog or Sonatype. And what we're able to do, and I'll show you a little bit more detail on this, is a layered image vulnerability analysis. And what that means is the ability to see at which layer each vulnerability exists, and the build commands for those, so that it makes it easier for the DevOps team to get back to the developer to let them know how to find and remediate that vulnerability.
Glenn, that's pretty awesome. And to just recap, I'm building a Docker image. Before anything else, I'm running some scans in said Docker image. Maybe there's a CVE in a module somewhere. I can trace that CVE back to the individual layer in said Docker image.
Absolutely, absolutely. And you know, you're going to have to decide on a case-by-case basis which vulnerabilities are critical enough, or that's where the DevOps teams meets with the security teams to find out which ones could possibly be exploited when it's running in production, because there are some even high-level vulnerabilities, but they're really not going to be able to be exploited when they're in production. So those may not be necessary to be remediated. So it's very easy to pick those out and then point the developer at that specific layer that they need to look for.
Yeah, awesome.
All right, so let's explain how the NeuVector CircleCI orb works. Like all orbs, first you're going to create the context for the NeuVector or the NeuVector job, and then you're going to provide some configuration information to enable the orb to reach the NeuVector scanner to trigger that vulnerability scan. So that's the NeuVector access. There's some configuration parameters as to either the URL or the IP address of where the NeuVector scanner is running. The second step is to add the NeuVector configuration to your config.yaml file. And CircleCI makes it very easy to specify this in a YAML file. You can see an example of one here to invoke the NeuVector orb. And you could see here that the job that's going to be run is the NeuVector scanner. And you can see various configuration options in there, such as the repository or image to scan, the tag. If there's a specific tag you want to scan, you can almost use a wildcard to scan any and all tags. Should this be a layered scan, or do you just want the summary that can be viewed at the top level of the Docker image? And most importantly, should there be a policy to fail this job and therefore fail that build pipeline if there are certain vulnerabilities in the image? And the configuration could include the number of high-level vulnerabilities or medium vulnerabilities to fail the image. In this case, if there's 3 or more medium vulnerabilities, it's going to fail. Or it can be specific CVE names or numbers that you're looking for.
Well, very interesting. And just to establish a little more context with contexts, context effectively are shared groupings of environmental variables. They're set at the org level, and we generally use context for things like secrets, like for API keys, or credentials we need to authenticate against the NeuVector registry, things like that. Very powerful feature. And then fun fact, we leverage HashiCorp Vault under the hood.
Awesome. So, you would put in the authentication information to reach the NeuVector scanner and trigger it, and then all of that's going to be stored in a secret in HashiCorp.
Precisely, yeah, and we leverage a pretty powerful secrets manager under the hood.
That's great to know. All right, and then once you've invoked the org, if you can go back, Chris, and triggered that scan, yeah, there you go. So either that scan is going to pass, which is the upper screenshot, or it's going to fail, which you'll see red, which that job has failed, and that build of that image will fail at that point. And you can click on the short reports or the long and full reports to see why this failed, and to actually view all of the scan results, to see all the CVE information in there, what it's going to take to remediate that. What is there a fixed version for that particular vulnerability? And that would be regardless of if it passes or fails. All that information will be available to you in this screen here at CircleCI.
Awesome.
So now that we've scanned the images, as I mentioned, we're going to make sure that none of those the vulnerable images don't get into the production environment. But let's talk about runtime security. This is really the last chance to prevent an attack. And so all of the attacks that you've been reading about, whether they're zero-day attacks or dirty cow SQL injection, crypto mining we've heard about a lot, are equally as likely to happen in a containerized infrastructure as they are in a non-containerized infrastructure. So that's why it's so critical to monitor the runtime environment. And your traditional security tools, like your traditional firewalls or endpoint security, is really not designed to monitor this dynamic container environment. They can't see vulnerabilities in that runtime environment. They can't see the east-west traffic or see the attacks happening, whether that's at the network level or a process is being exploited. So what's really happening is that your traditional tools were designed for an environment where it was like a DMZ and a data center environment. But the world is moving to more of these dynamic hybrid cloud environments. So the perimeters for security are blurring, and you really can't use those perimeter-based tools to secure your workloads. You really need to follow or build security around every workload, and it needs to follow that workload wherever it goes.
Absolutely.
So if we look at some common attacks, what's the common factor in all of those is that there's a kill chain. A successful attack is never just one security event. It's a kill chain of events. And those are, from left to right. It could be a reconnaissance to find a way into your infrastructure. That could be through a phishing attack, or it could be just through a port scan. And then there's a series of steps, moving around internally, looking for something to exploit, or downloading an exploitable package or malware, maybe reaching out to a command and control server, and then finally a data stealing. So there's a number of events in that kill chain, and there's a number of opportunities for security people to be able to detect that there's a kill chain happening. The most critical part of that is the network, because they're going to have to use the network to get in, to spread laterally, as well as to steal data, maybe even in the interim to connect to a command and control server. So the network is the most critical aspect to really have great visibility into. But you also need to monitor the container itself. What's happening in that container? Is there anything suspicious happening? Is there malware being downloaded? Is there files being accessed that shouldn't be accessed? As well as the host. What's going on on the host? Is there a privilege escalation that's going to enable somebody to take over the Docker daemon? Or is there a container breakout that is happening that's going to allow them to gain access to the host? So there are multiple vectors to monitor during runtime. So one of our customers is John Deeming, VP at Experian, and if you're wondering, no, they're not the ones that got hacked. That was in the news. That was Equifax. But John, recommends that you take a serious look at what's happening in your network, because it can get pretty complicated when you have hundreds of servers and hundreds of or dozens of Kubernetes services or workload services and thousands of containers all connecting to each other. How do you make sense of it? How do you identify where a kill chain is happening?
Yeah.
So as I mentioned, we're a full lifecycle container security platform. Our product is a container itself, so you would deploy NeuVector just like you deploy any other container workload on your infrastructure, and it's managed and updated just like any other container. And as soon as we're deployed, we're able to start looking at all the network traffic. We're able to do all the shift left registry scanning, admission controls, run the CIS benchmarks, and do all of the runtime activity monitoring that we talked about. And I'll show you a brief overview of the NeuVector console in a minute.
Yeah, that would be great.
So now that I talked about one of the challenges for DevOps and security teams is the pace of this CI/CD pipeline and how quickly things are moving into production. And how do you build security into that process or that pipeline and not hold up your DevOps or your developers? So the first step, of course, we talked about, which is automated triggering of the NeuVector scanner using the CircleCI ORB. Now, once you've done that, the ability to automate all of the aspects of security that NeuVector provides is also critical. So DevOps teams are going to want to do the vulnerability management during the build phase, but also at runtime as well, and in registries. They're also going to be able to create what's called a workload security policy. And that security policy, which is in the form of network rules and process baseline rules, basically the allowed activity that every container should be allowed to perform. And those rules can be defined in what's called a CRD, or custom resource definition. That's a Kubernetes construct which enables DevOps teams to work with the developers, characterize the application behavior, and then build that into a YAML file. And that can then be deployed along with the application so that the security follows the application into the production environment. So once you're in the production environment, then the operations and security teams they may have some global network and workload rules that are not application specific, and they can use the same construct like the CRD to programmatically create those rules. They can also use the REST API of NeuVector, or they can manually do it the old way by going into the console and building firewall rules and process rules in the console. So it really, we're really moving to an environment where this vision of security policy as code is becoming a reality with the combination of config maps and CRDs and all of these things that Kubernetes brings.
Absolutely.
A couple things that I wanted to highlight in terms of runtime detection. Because we're able to see all of the packets and network connections and do deep packet inspections, here's a couple things that you can do. You can look for unencrypted credit card information. You can look for PII or any privacy data that is either being stolen or being sent pod to pod unencrypted, and it should be encrypted. So you're able to actually look into the network payloads to look for those types of privacy violations. Now, a number of you may be looking at what's called a service mesh. It's a layer of application routing and application services that is a very exciting open source project. Most famous one is called ISTIO, but there's also Linkerd 2, and most of the public cloud players have their own versions of ISTIO. And so when you deploy ISTIO, it's going to help you do many cool things like blue-green deployments and URL-based routing of applications to different versions. You can also do encryption for pod-to-pod traffic. The cool thing about where NeuVector sits in that layer is that we are still able to inspect the network traffic even if ISTIO encryption is turned on. So we're able to inspect the network traffic, make sure that it's authorized, make sure that there's no embedded network attacks in it before the ISTIO sidecar proxy is going to encrypt it. And on the other end, when that proxy decrypts it, we can again inspect that network traffic. So we can provide all of the network protections even in a service mesh environment. And in addition to that, we're going to be able to also monitor all of the control plane traffic that ISTIO generates. And there's quite a lot of that because each workload is going to have a sidecar proxy running in it. And so if you have 1,000 containers, you're going to have 1,000 ISTIO proxies all communicating to the control plane, all potential ways to hack into it or to exploit vulnerabilities. So we're going to monitor that for you as well.
Yeah.
Now, another exciting concept is that companies are moving to not just single Kubernetes cluster deployments, but ultimately the ability to scale workloads either for performance reasons or availability reasons across clouds or hybrid clouds. So that could be across multiple public clouds, or that could be within a public-private cloud, hybrid cloud environment, or multiple private clouds. Doesn't really matter. As you get these multi-cloud environments, then it will become critical to have a central location to be able to manage your security policy, do the vulnerability scanning, view the results that we talked about, and see a perspective across all of your clusters. That could be used by the DevOps or security teams, but it can also be used by the global security team to define global policies, which are then federated or pushed down to each cluster.
Yeah, this is really interesting stuff. And this paradigm, broadly speaking, we refer to as policy as code.
Exactly. Policy as code can be defined by either the DevOps or the security teams and pushed into multiple clusters, either with the workload as they deploy. Let's say you deploy your MongoDB and your application across multiple clouds. You can push the security policy along with that, deploying that application across multiple clouds.
Awesome. Yeah, being able to automate application security in the overall SDLC. It's really interesting stuff.
Absolutely. Okay, so let me show you a quick overview of NeuVector that gives you a little bit a better perspective of how we run. This environment here is actually running on a public cloud. It's a AWS EKS environment, but it would look the same whether you're running on private cloud, on Azure, IBM. It doesn't really matter to NeuVector. You can easily see that we've discovered all of the containers running in the infrastructure. There are 4 worker nodes in this cluster, and NeuVector, as I mentioned, is a container. So we have what's called an enforcer container, and that's deployed as a daemon set. So Kubernetes puts one on every one of these worker nodes, and those are managed in a control plane by the NeuVector controller. The leader is elected automatically, and these other ones are here for HA reasons. So once NeuVector is deployed, we're going to discover all of the network activity in the containers, like you see here. And we're also going to be discovering and baselining all of the process activity and all the file system activity in every container. So you can see here that we've discovered that the Nginx pod is talking to these Node.js pods using the HTTP protocol. And we've created a whitelist rule to allow that connection through. And we also see that the Node.js pods are talking using the Redis protocol, and we've created a layer 7 whitelist rule number 7 to allow those types of connections. And once you review those and you lock the environment down, you can see if I right-click on one of these pods, it's been moved from the discover mode into the monitor mode, where now you can think of it as being locked down. Any network connections, any processes, any file system activity that's not been baselined or whitelisted is going to be flagged as a security violation. In the protect mode, we're actually going to block that activity. So we're going to block a connection, we're going to block a process from starting, or a file system access. So you can see here there's a number of violations that we're showing. The first is the lateral movement that I talked about. So if this Node.js pod is hacked and tries to move over to this other pod here, that's not an allowed connection because Node.js pods shouldn't be talking to each other. And that's why we are flagging that as suspicious activity. There's no whitelist rule to allow that. Here we've got what's called a ping death attack. So we have built-in protection for different types of network attacks like SQL injection attacks and DNS attacks, tunneling, a number of different network type of attacks. This type of attack is just a MySQL access where somebody tries to guess a MySQL password. So there's a number of things you can see going on here. And by the same mechanism, if there's any suspicious process that starts up in a container, we're going to also monitor and alert you about those. Now, if you're in an environment, you can also see the active network sessions. You can start a packet capture. You can even quarantine a container to block all network sessions in or out of it. And you can see here that yesterday there was some suspicious activity and a packet capture was automatically started, and that can be downloaded as a PCAP file so you can see historically what happened to generate that suspicious network activity. So that's all of the runtime protections. Now, we started this webinar with talking about the pipeline. So we talked about the CircleCI ORB and how we can trigger during the build phase. And then the images go into a registry. Here is where in NeuVector you would scan the registry. So you configure, there's any number of registries that we support, all of the popular registries. And this is the layered scan result that we talked about, Chris. And that's there are 54 high vulnerabilities in this Node.js image, and at this layer is 4 of those high vulnerabilities. And this was the command used to build this layer. So it makes it very easy for the the DevOps team to communicate back to the developers when they want to have them remediate a vulnerability. And then the next step typically is to define one or more admission control rules. And that's where, for example, we could say if there are more than 20 high vulnerabilities, probably be a much lower number, block this deployment. So you can see here, you can add any number of whitelist or blacklist rules. And that can be based on the image scans that we've done, the counts, or the specific vulnerability names. But it can also be based on, let's say I only want to allow deployments from a specific image registry, or they need to be labeled a certain way, or only deployed into a certain namespace. So it's a very powerful tool for linking the CI/CD pipeline and the vulnerability scanning earlier in the pipeline with the runtime environment to prevent vulnerable images or unauthorized images from getting into production. And then once they're in the production environment, you could see here that NeuVector will also automatically scan all of the containers in the production environment. So any container that starts to run, NeuVector will scan that for vulnerabilities. We'll also scan the hosts that the containers are running on, and the Kubernetes platform itself, because that could have vulnerabilities, as we heard late last year. We also run the CIS benchmarks, and those can be either manually run or automatically run. So to kind of sum it up, we do the runtime protection, we do the full lifecycle CI/CD protection. We will summarize your exploit risk score in a summary by calculating the risk of these vulnerabilities being exploited. And if you've locked down your environment in either a monitor or protect mode, your score will be lower than if they're in a open or discover mode. Even if you've got critical vulnerabilities running in production, if you've put those pods into a monitor protect mode, NeuVector is going to detect any suspicious network activity, processes that start, or file system activity. So there's virtually no risk that that vulnerability could be exploited without you being alerted, and NeuVector detecting that either with file system, process, or network activity detection. All right, so that's a quick overview of NeuVector, Chris. And any final thoughts, Chris, before we open it up to questions?
Glenn, that was absolutely great. Thank you so much for that comprehensive walkthrough. I would encourage folks now to start asking questions. But Glenn, maybe if we could just kind of start the conversation, if you wouldn't mind telling me just a little more about NeuVector, the company's history, how long have you been around, how many employees?
Yeah, NeuVector was founded about 5 years ago. Our founders come from backgrounds at companies such as VMware, Trend Micro in the security space, and Fortinet, which is a layer 7 firewall company. And so you can see by our founders' backgrounds that we've really combined traditional security, including endpoint and DLP, with experience at VMware, so virtualization. What's the next wave of virtualization? Well, it was virtual machines, and then it was moving into containers, which is really the next layer of virtualization. And what are going to be the security issues when that virtualization of applications happens? And then one of our other co-founder, Gary Dwan, wrote all the deep packet inspection engine algorithms at Fortinet. So that's where all of our networking and deep packet inspection expertise comes from. So we put all that together, initially focused on making sure that if companies were running in production, that we could protect them with a firewall and with the network and process inspection. But as I mentioned, we've expanded really to the entire full life cycle. Our customers really, no surprise. I'd say a large percentage of our customers are financial services, insurance, basically any type of company that has sensitive data that's very valuable that they want to protect in a production environment. So a government, I'm surprised that there's a lot of government entities that are deploying, but of course they have a lot of sensitive privacy data that they need to protect as well.
Awesome. Well, Glenn, if you wouldn't mind, can we just talk a little bit about how NeuVector is priced?
Sure. NeuVector
folks
is
who might
priced.
be interested in getting started and incorporating NeuVector in their pipeline.
Yeah, I mean, I'm curious as to how CircleCI is priced as well. But NeuVector is priced on an annual subscription. And the way we price NeuVector is, you saw that the NeuVector enforcer is deployed on every worker node that we're protecting. And so we price the annual subscription based on the number of worker nodes or hosts that our customers are protecting. We also, if our customers license 10 worker nodes in a production environment, we also provide an equivalent number of free development licenses to use earlier in the pipeline.
Gotcha, yeah. A little bit about CircleCI's pricing. So historically, we had a container-based pricing model where we would sell containers effectively, 2 containers, 10 containers, 20 containers. And at that point, an organization was effectively limited to that number of containers. So you could use one of those containers for maybe a simple project. Maybe you're using 10 in a complex workflow, but you were kind of capped out at 10 containers at that point. And about 1.5 years, 2 years ago, we built functionality around usage-based pricing, very much like AWS On Demand, right? Where you're paying for the resources you use as you use them. And this has been great because now effectively you can just, you can scale unlimited. There's no limit to the scaling, if you will, right? So now an individual can run a single build for a very simple project. You can take that back to your organization at large. You can run 1,000 builds in parallel. You're really just paying for the resources you use when you use them.
Yeah, and similarly, we are also planning to offer as another option usage-based pricing. So if they're running in a public cloud environment, you can have auto-scaling environments in production. So you can scale from 10 to 15 nodes if you get busy for a day or a week. And so we want to make sure that our pricing model is aligned to all of the public cloud provider pricing models as well.
Precisely. Just want to pause and encourage some of our viewers to put forth some questions. What was I going to say? Yeah, I was going to say that the usage-based pricing seems to be the general trend in the industry.
Yep.
I was also going to say that we have a pretty generous free tier. So we give everybody on GitHub and Bitbucket, I think, at least 1 free container, possibly more. Possibly more. But everybody gets, bare minimum a free container to, run a Hello World program in and get their hands on the platform.
Yeah. Is that time-limited free trial?
Ooh, excellent question. You might have a number of build minutes. You might. But I do think everybody on GitHub just has a free container to experiment with.
Yeah, we do offer free trials. We tend to manage those more closely because we tend to manage more, in a production environment with networking rules and things like that. People are very concerned about, okay, what is this going to do to my network? Can you help me make sure that I've set up my network properly so that my containers can communicate to each other? Make sure you have the right visibility. So we like to work with those customers to make sure that everything is set up properly.
It's the same on our end. So when we conduct a formal 2-week trial with a customer, we give them carte blanche access effectively to the platform. And we use this period to kind of gauge what their overall usage is going to be like moving forward. But it's so important for us to have some guardrails on in that period to make sure they're set up properly, make sure that there's some high-level success criteria, that all of us are kind of in alignment with regards to what we're trying to accomplish. Mm-hmm. To your point, right, I mean, when we're kicking off a full 2-week trial, I mean, we're touching people's source code, right? So it's just very important that we're all kind of in alignment. Everybody's got our ducks in a row, et cetera.
Mm-hmm. Yep.
Are most of your engineers in San Jose?
Yeah, our headquarters are in San Jose, so our main team is in San Jose, with the exception of our field teams that are throughout North America as well as Europe, and in Asia as well.
Gotcha. And if Glenn, if you already answered this, apologies, but please remind me, how many employees do you have?
We're going on 30. We're going above 30, so we're on our way to 40. So still a small company, but
Oh, wow.
going to scaling up rapidly and starting to experience those growing rates.
Yeah, that's a very exciting time to be at a company. I was employee 32 at CircleCI, and I think we're at 250 now.
Wow,
Yeah.
that's awesome.
Yeah. Final pause for questions for our viewers. Well, Glenn, if there aren't any other questions, I want to thank you so much for your time today. This has been really, really insightful.
Thank you, Chris. Appreciate it. It's good to learn about CircleCI, and we're happy to work with you guys.
Oh, you know what, Glenn? Looks like we just got a couple of really interesting questions. I don't know if you can see in the chat. The first is how LDAP and role-based access controls work on both products.
You want to go first? Yeah.
On both products. Excellent. All right. So in the context of our on-prem offering, so CircleCI, we come in two flavors. We have a cloud-hosted service. Most of our customers, the vast majority of our customers are cloud users. We do have an on-prem solution as well. We package it with Terraform. Our on-prem offering, we do have an LDAP integration. In the context of our cloud offering, if you were using LDAP to authenticate against GitHub or Bitbucket, we would effectively piggyback off of those permissions. Hope that answers your question. And then Glenn.
Yeah. For NeuVector, we support LDAP, Active Directory integration, OpenID, single sign-on as well. So all of the users and groups can be integrated and mapped for access to NeuVector. And then we have for RBAC, we do have a special integration with OpenShift, where you just click a button and we'll read in the OpenShift project RBACs. So if you have access to a certain project in OpenShift, then you can be mapped into NeuVector to either just have read access or admin access into NeuVector as well.
Awesome.
Just for those projects.
Awesome. Yeah, and then a follow-up question, incidentally, was do you support OpenShift?
Yeah, we have, of course, we support OpenShift. We run on OpenShift. We have some special integrations with OpenShift. One of them is the RBAC that I talked about. Another one is the image streams, where if you're using the OpenShift registry, if you put a new image or update an image in an OpenShift registry, the image stream will notify NeuVector, and then you can just scan that right away. So it's kind of like a triggered scan as opposed to a scheduled scan. And then, as I mentioned, we have the admission control capabilities, and that is integrated into Kubernetes and OpenShift, the admission controller. Yeah.
Awesome. Awesome. I guess, Glenn, we've spent a lot of time talking about Kubernetes, but I'm curious if NeuVector has other integration points with maybe other cloud providers, other technologies.
Sure. Yeah, we talk a lot about Kubernetes because it's the most popular platform.
It's all the rage.
But any Kubernetes-based platform like OpenShift, Rancher, PKS, all of those are supported by NeuVector. But if you're running Docker EE as well, or just Docker native containers, those are supported as well.
Awesome.
And we support multiple runtime engines as well, whether that's the Docker engine or the Containerd runtime or the Cryo runtime.
Oh, very interesting. And, we've spent a bit of time, throwing the term, layer 7 security around, but maybe, before we drop off, just articulating what exactly that means for the benefit of our viewers.
Sure, that's a good question. Layer 7 is in the networking stack. It's basically
model.
Exactly. It basically means application protocol layer. And so there's layer 7 and deep packet inspection. Those kind of are similar terms, but slightly different. So at layer 7, we're able to inspect all of the network protocols. And therefore, you saw those rules where we can we can create a rule that requires a MongoDB or a MySQL protocol between two pods. And you don't have to create a firewall rule based on layer 3 or 4, which is IP address and port.
Yeah.
It's a much more flexible rule. You can scale up pods and down, and you only have to look at one rule, which is this service can talk to this service over this protocol. And it doesn't matter if you have 100 pods running on that service. Now, deep packet inspection also gives us the capability to do the things that I talked about, which is looking into the payload in the network stream for things like credit card data or sensitive data in the payload as well.
That's awesome. All right. Well, if there are no other questions, Glenn, thanks again so much for your time today. This has been great.
Thank you, Chris. It's been our pleasure.
Appreciate it. And thank you to all the viewers for watching. Talk soon.
Bye, everyone.